Now is the turn of Sara. Sara Ayuso Candal is a biology researcher technician dedicated to oceanographic research and the study of global water quality. She carries out her work within the framework of the program Canary Islands, a reference for the study of global water quality from the Promotur subproject number 6, and where she participates in the implementation and analysis of oceanographic time series data at the IEO. The talk that will present Sara is titled A Study of the Distribution of Inorganic Nutrients in the Natural Fertilisation Induced by the Submarine Volcano Tagoro, El Hierro, and the Effect of Sample Freezing. So, good luck. You have, tienes 15 minutos, te lo dejo aquí así. Para que lo puedas ir viendo.
Thank you, Claudia, and thank you everyone for coming today. I'm going to continue with the early career talks by presenting my master thesis. As Claudia said, it's about the spatial distribution of inorganic nutrients in the Tagoro volcano in El Hierro Island and the effect of sample freezing. Let's start in October 2011, when the Tagoro volcano began its eruption. This eruption led to important physical and chemical anomalies in temperature, pH, salinity, and PCO2. This left an ecosystem destroyed and without life. The Spanish Institute of Oceanography has been monitoring this volcano since the very beginning, being a unique opportunity to learn about this extreme ecosystem. Technical difficulties. Okay. After the eruption, the volcano began its post-eruptive phase, or degasification phase. In this phase, the Tagoro volcano confronted its final shape, which is 1.3 kilometers of diameter, with a crater at 127 meters depth, and a summit that remained 88 meters below the surface. This phase is mainly characterized by the emission of hydrothermal fluids, which are very common in the Tagoro volcano area. And these fluids are rich in gases, metals, and inorganic nutrients, such as silicate, phosphate, nitrate, nitrate, and ammonium. The study of these inorganic nutrients is very important to understand the biogeochemistry of this oceanic production. And I want to put in value as well specifically the silicate, because a lot of researchers are known to have problems when measuring this kind of nutrient, because it is known that the silicate, while it's found in the ocean as free radical, when it gets long-term frozen, it gets polymerized, causing some imprecision during the analysis of this nutrient in the laboratory. But this can be easily minimized by undercoming these nutrients under a heat treatment. For all of this, we went on two cruises, Vulcana on April 2021 and Vulcana on January this year, on board of the research vessel of Ángeles Alvariño. We took samples in two different places, one around the Tagoro volcano, where we designed a grid of different stations, as we can see here, classified depending on their distance to the crater. So the yellow dots would be the stations that are farther away from the crater, the green ones are the medium ones, and the purple ones are the ones that are closer to the crater. We can also see some blue dots over there, which are the samples that we took straight from the hydrothermal vents. We also sampled on an area farther away from the Tagoro volcano, so we could have a reference. Both of the samples, the samples taken in April 2021 were sampled with an oceanographic rosette, while the ones taken this year were sampled with an ROV, which is a remotely operated vehicle, which allowed us to take the samples straight from the hydrothermal vents. The samples were all kept frozen. Kept frozen at 20 degrees, minus 20 degrees, for their conservation, so we could analyze them in the laboratory later. In the lab, we got the concentrations of silicate, phosphate, ammonium, nitrogen, nitrate, and we processed these data using the programming language of MATLAB, which allowed us to do some statistical tests like Kruskal-Wallis and mul-compare, and also to represent our data. On MATLAB, we also decided to design two transects so we could represent our data. So it would be a latitudinal transect that crosses the summit, which would be the station number 20, and the crater that would be station number 31. And then a longitudinal transect, which crossed only the crater. And for the study of the freezing effect of the samples, we decided to take samples from two different dives, dive number 5 and dive number 11. And each week we would defrost 4 samples and let them defrost at room temperature, meanwhile we left another 4 samples to defrost at using the thermal treatment at 50 degrees and for 30 minutes. And all of this took a time of 12 weeks. And now for the results. First of all, we compared the concentration of each nutrient, also having in mind all the classification of the stations, depending on the distance to the crater. And the statistical tests revealed that there were significant differences between all stations, except the closest and medium ones, and for all nutrients. And more specifically, as you can see on graph A and graph C, there were significant differences between the ROV and all the stations for silicate and phosphate. We also decided to calculate the enrichment for each nutrient, always classified as groups. And I just want to point out here the silicate, which got an enrichment of 57 times higher than the reference station, as we can see in graph A. And but there were also enrichments in all of the nutrients depending on the group of station measured, as has been reinforced but by different researchers. Then we decided to represent our data. We decided to calculate the anomalies of each nutrient. So here we can see the vertical contours in the 2 different transects I talked to you about. And for I want to point out for silicate and phosphate that there you can see the positive anomalies that are usually near the crater and the summit, while the negative anomalies are found a bit farther away, and in case of silicate, even at higher depths. We must have in mind the cyclicity of the volcano, because the volcano is not continuously emitting these flux. It emits like pulses of fluids, which condition the measurements of these nutrients. But it can also be explained with the convective cells that work this way. When the volcano emits these fluids rich in inorganic nutrients and with high temperature, the fluid goes up and it replaces the mass of water that is at lower depths. And this mass that was before near the surface goes down in a way that the surface gets a higher concentration of nutrients, and the lower parts are left with a lower concentration. This can easily be appreciated here with nitrate, where you can see a first layer of positive anomalies, followed by a negative one, and then another one of positive anomalies. And finally, for the study of the freezing effect of the samples, as we can see, there's, in general, I want to first point out that the dye 5 had higher concentration of nutrients for almost all nutrients than the dye 11. And if we focus on silicate, we can see that meanwhile the dye 11 is completely plain. There's no difference between the heated samples and non-heated samples. On the dye 5 with higher concentration of nutrients, you can see that there's a quite big difference between the red line, that are the samples that went through the thermal treatment, and the orange line, which is the samples that defrosted are at room temperature. This is very important, as I said before, because there's not much information about this. There's some papers that talk about the limits at which the freezing effects affects the samples. But here we find out that even at 40 micromole kilo, these freezing effects affects the measurements of the samples. Thank you very much.